Hello, my name is Captain Ben. I'm with the Chesapeake Bay Foundation, and today we're going to do a dissection of the eastern oyster, or, for Latin, Chrysostrea virginica. This animal right here is the oyster. It may look like a rock, but this is a living animal. What do animals need to survive? I would say they need protection from predators, they need to be able to eat, and they need to be able to reproduce. Today, we're going to run through all three of these factors and check out the incredible, edible oyster. Here we have two different oysters. One of these oysters is alive, and one of these oysters has already died. Can you tell the difference between the two oysters? Which one is alive and which one is dead? If I squeeze both of the oysters, you might be able to tell. This one here, when I squeeze it, nothing happens. When I squeeze this one on my right, check this out. Look at that small amount of motion. That oyster is already open when I got it, and therefore I can tell that this oyster has died. Inside of their shell, they have a muscle called the abductor muscle, which they use to keep their shells closed when they think a predator is around. And I definitely am a predator to these oysters. So, if they're dead, that muscle is relaxed, and therefore their shell will open. The oysters that I'm going to use today for this dissection, I bought at a seafood market, and they came from an aquaculture operation in Saxes, Virginia, which is over on the eastern shore of Virginia on the bay side. Oysters that come from aquaculture operations still provide all of the same benefits that wild-caught oysters do to the bay's health. If this oyster over here on the left is alive and is able to keep itself closed nice and tight, what do you think could be possible predators for an animal with a hard shell like this? What might be able to eat this oyster? So if we look at this oyster, we can tell that this oyster cannot move around. They are what scientists call sessile beings. On this oyster, if you look right here at this curved spot, that right there is where this oyster, when it was still out in the bay, was stuck onto another oyster. Maybe this one that I'm holding in my hand here. Probably not though, because they came in a big bushel. So, these sessile animals can't move around, but like all other animals, they need to be able to find a mate to reproduce. So, the way that these oysters reproduce is by being what scientists call broadcast spawners. When the water reaches 74 degrees, this oyster will release a cloud of eggs or sperm out into the water. Those eggs or sperm will float around in the water column and meet up with each other. When they meet together, they will form into an oyster larvae, which will float around in the water for about 2 weeks. At the end of that 2 weeks, those larvae will grow a foot and they will sink down to the bottom. The oyster larvae will scoot themselves across the bottom, using their foot to taste along as they go, trying to find something hard that the oyster can stick to and stay in that one place for its entire life. They will use, right at their hinge, they will attach onto a hard substrate, preferably another oyster shell, and they will grow from that point for their entire lives. Once the larvae attach to something hard, they form their two shells and start to open and close while eating algae and starting to grow. At this point, we call the oysters spat. These spat will grow, eat and grow, and eat and grow until they reach adults and they can start to reproduce. Each adult oyster will filter up to 50 gallons of water per day just to eat the algae out of that water. Then, once they're adults and the water starts to reach 74 degrees Fahrenheit, they're going to start this whole cycle over, and start to clap out eggs or sperm into the water, which will meet, make the larvae, sink to the bottom, grow themselves, and keep living on in their little oyster lives. So I've been saying that these oysters clap eggs or sperm out into the water, and that means male or female. How can you tell the difference between a male or a female oyster? The easy answer is by the oyster's size. Larger oysters are female. Smaller oysters are male, usually. This means that since the oysters grow larger as they get older, that oysters will change their sex during their lifetime. Scientists call them sequential hermaphrodites because of this fact. Oysters that are smaller tend to be male, as it takes less space and less energy to have male genitals inside of their shell. Larger, stronger oysters tend to be female, as it takes more energy and more strength to produce the eggs needed for reproduction. What's super crazy, though, is that near the end of their life, as the oyster starts to get old and frail, the oyster can switch back to being male, as it's easier to maintain. Or, if on the reef the oyster senses that there are too many eggs or too much sperm in the water, they can change their sex to make it the ratio work out to increase reproduction. So at the beginning of this video, I said that this was going to be an oyster dissection. So let's get to opening this oyster up and seeing how this oyster does the magic that it does to save the bay. So we're going to take this oyster and I'm going to open up the two sides of the shell using one of these shucking knives that you've seen here on the side. This right here is called a hinge knife. You use it and you have to come in at the hinge of the oyster. Right back here at the pointy end of the oyster, you can see there's these two separations in the shell. You can get the knife right in between there and then twist and open up the oyster. Another way to open the oyster is to come through the bill of the oyster. But those knives, the bill knives, are much wider and flatter, and you get in there. To open the oyster, you have to get the two sides of the shell apart, and then move the blade up and cut that abductor muscle that they use to keep their two shells pulled together. I'm going to do that now. So I've cut the oyster stomach open to take a look at what this oyster was eating for lunch. So this oyster, we can see the mouth right down here, and then right next to that we find the stomach. Look inside. This is the stomach contents of the oyster. This is what all the algae in the water looks like. Doesn't this color remind you of the color of the bay? It's because that is the stuff that makes the color in the bay, all of that algae. Inside of the oyster's stomach, they have a super cool free-floating organ known as a crystalline style. It's very hard to find because it is see-through. Now, when I say free-floating, I mean that organ isn't attached to any other part of the oyster's body, which is crazy. Now, the oyster uses that crystalline style to move around inside of its stomach like a blender blade, similar to how birds use stones that they keep in their gizzards to help them break down seeds and nuts and things that they eat. Now, if the oyster is ever in a time of famine, where it can't really get any food, if, say, we're kept out of the water, like these oysters that we have at market usually are, then they're able to digest that free-floating organ and use it for energy to keep living. Isn't that awesome? So now we're moving through the digestive system. We have the cilia coming down here and the gills that catch the stuff, bring it to the mouth, and eat all of the things, separate out the algae and the sediment. We have the stomach that breaks down the algae, and then we have the rest of the digestive system, or the intestines. If we look closely, we can see coming from the stomach, you have a tube that goes down here, wraps up back along that abductor muscle right there, and comes out right here at the side of the shell. Looks like I may have nicked it right there. But if it's after the stomach, what do you think that tube might end up as? That's right, It's the rectum. Now, what's really funny here is if this oyster's digestive system had been working, if it had been eating, then maybe I can just make this oyster poop for us. And isn't that fun? Give me a second and let's watch that. So I'm going to take the side of this knife and I'm going to squeeze up the oyster's intestines towards the rectum and try to squeeze some poop out of it like toothpaste. Let's see what happens. So, right here, oh yeah, oh there it is. Right there we can see the end of the rectum and some poos coming out. That's because this oyster had been eating. Full-on vegetarian diet, eating the algae out of the water, but that right there on the end of the knife, that is the end product of oysters saving the bay, making it a cleaner place for everything else to live. That right there, 100% full-on feces. Not the pseudo-feces from the other end, but real feces. So that brings us to the end of our oyster dissection, and I'd just like to talk about one other thing that makes them one of my favorite bay critters, and that is that you can eat them. Oysters taste mostly like the seawater around that they live in because of that open circulatory system that they have. Also, when they're alive, they sanitize themselves with that powerful immune system, which means that if you take an oyster out of the bay, open it up, and go to eat it, you'll probably be fine. Also, they don't taste like dirt because they make that pseudo-feces. They spit any of that dirt out, and that leaves them tasting like salty little delicious nuggets. I also like to put a little bit of lemon on them before I eat them, and that just makes them taste even better. So, here goes. Even though I've already eaten this oyster is not yet done saving the bay. If you take your spent oyster shell and bring it to a oyster recycling center, they can attach baby oysters to that shell and put it back out in the bay and increase the amount of oysters that are living out there.